Good evening. Welcome once again to my channel. Please subscribe, like, and share the video to motivate me to produce more videos like this. Last time we looked at how to determine the ground state term for a D5 atomic orbital. Today I want us to look at how to determine the ground state term for a D6 atomic orbital. First of all, we need to write down the angular orbital quantum number, represented by L. For d orbital, it is 2. Then the magnetic quantum number. The magnetic quantum number begins from plus L, 0, and negative L. So since the L is 2, we begin from plus 2, plus 1, 0, negative 1, negative 2. Then we know that the spin quantum number can either be plus half, because an electron can spin upwards or can spin downwards, which is represented by negative half. Then we write down the orbitals. D orbital is a 5-degenerate orbital. Then we write down the magnetic quantum number of each orbital. The next is to fill the orbitals with the electrons. We have 6 electrons. So we'll fill the orbitals with the electrons by obeying the rules in filling orbitals with electrons. So in this case, we have to obey the Hans rule. According to Hans rule, if we have a degenerate orbital, we have to first fill the orbitals with single electrons in the same spin. Before we pair up in an opposite spin. Since we have remaining 1 electron, we pair up here in opposite spin. The next is to determine the total orbital momentum quantum number, represented by capital M and L. In this case, if we take into account the first orbital, the magnetic quantum number is 2. So first of all, to determine the total orbital momentum quantum number, we have to sum up the magnetic quantum number of the orbital that contains electrons. Since the first orbital contains 2 electrons, we need to take into account the 2 electrons. So the magnetic quantum number, instead of 2, becomes 4. Then this only 1 electron, the magnetic quantum number is 1. Here is 0. This one is negative 1, and this orbital is negative 2. So in all, we have 5, minus 1, 4. Then minus 2, we have 2. Then we determine the total spin quantum number. To determine the total spin quantum number, each electron spins either upwards, which is plus half, or downwards, which is minus half. This orbital contains 2 electrons. This spins upwards, which is plus half. This spins downwards, which is negative half. So plus half, negative half, they cancel each other. So let's ignore the first one. Now let's focus on the rest. All the orbitals contains 1 electron, and they all spin upwards, the same direction. So for the first orbital, the magnetic quantum number, the spin quantum number, is plus half. For this, is also plus half. Then the last one is also plus half. So the total becomes 2. Then we determine the spin multiplicity by using 2s plus 1, where the s represents the total spin quantum number. So we have 2 here, plus 1, so we have 5. According to the previous video, we know that if the total orbital magnetic quantum number is 2, then the term is a D term. So it's a D term. And since we have the spin multiplicity to be 5, we indicate the spin multiplicity here. So the ground state term for a D6 atomic orbital is 5D. Thank you.